I'm pleased to introduce Pat Quinn from Curtiss-Wright. We'll introduce the flight test instrumentation COTS solutions for hypersonic missile test.
Thank you very much. Morning, everybody. Good to talk to you again. So I'm going to present a paper on FTI solutions for hypersonic missile test. Sorry, clicker issues. Working? Anyway, so it's a graph of some of the hypersonic missiles, past, present, and future. You can see hypersonic flight pretty much stopped after Concorde, and then it's coming back in a big way now. And you've got the standout ones like HTV-2 and Avantgarde up at Mach 20 flying there, and there's some future ones like the Boeing Hypersonic Concept and Hyperstar coming in the late 2020s, 2030s. Some of the future vehicles. So when it comes to missile test itself, there are multiple phases of the missile test, and each one has different requirements on the data acquisition system you want to put on it. One of the first ones is captive carry. This is where they connect the missile to the wing of the aircraft it will be launched from, and they measure shock and vibration and stuff like that to make sure it's not affecting the performance of the aircraft itself. Right? A lot of that in that it's just a lot of vibration measurements, stuff that you're taking. After that, then there's propulsion tests. These are shorter flights, typically air launched. When you're air launching missiles from an airplane, the environments are different than a ground launch. Air launch is much colder, about -50. There's also an acoustic noise requirement in air launch that we wouldn't care about in the ground phase. Then sometimes they move on to ground launch. Again, ground launch not being up at 30,000 feet would be temperatures would be way less extreme than air launch. So again, the environmental requirement changes. So because you have these different environments you're operating in, the module selection will change with the test phase, what you're measuring. So what you want is a configurable stack to allow the customer to configure the same stack for each phase of the development. So when it comes to hypersonic flight, some of the challenges are power. So sustained hypersonic flight requires typically scramjet engines. So you can see a diagram of a scramjet engine there at the inlet body, fuel injection, and the nozzle with a supersonic exhaust coming out the end of it. The other one that's been mentioned a lot of times in the papers the last couple of days are shockwaves. Shockwaves can result in high temperatures that can cause chemical reactions to occur. So for example, the air molecules can become ionized, and that can introduce radio blackouts, which interferes with your telemetry stream. The exact speeds of the phenomena are dependent on the geometry of the vehicle and the air pressure. So how you shape the vehicle affects the shape of the shockwaves. When you're, again, flying at hypersonic speeds, temperature is a big problem. Air friction can result in temperatures exceeding 2,300 degrees. So you have to use special materials for hypersonics. You can't use steel, because steel melts at 1,370, titanium melts at 1,670. So now they're building these missiles out of composite materials. One of the other main challenge of hypersonic flight for missiles is how do you get good data back? How do you get your telemetry back at speeds in excess of Mach 6? Typically, in the past, they would have used chase planes or multiple ground stations over the path of the missile. They fired the missile out and it'd be coming over multiple ground stations. When you're going at Mach 6 or Mach 20, that might not even be possible. So satellite comms is something I see coming up in the future for a flight test, where they offload to a satellite possibility. So when you're designing your hypersonic missile FTI system, the challenge is these missiles are small and compact. You want to reduce the number of individual boxes required on board and compress all required components into a minimal space. You want to make sure it meets the high shock and vibration requirements. It must be rugged enough to handle all environments. Ensure it meets the operational thermal requirements. Can it handle the heat that's going to be generated? What heat will it generate itself, and how do you get the heat away from the unit? You have to be careful how you mount these things. It must be field adaptable to meet the changing requirements of the flight test programs. You have to be able to adapt it for different measurements at different stages of your flight test. And again, ideally, you would use standard flight processing software for quick analysis of the flight data. You don't need custom software for this stuff. So looking at what the components of an FTI system for a hypersonic missile typically are. You have sensors and avionic data that go into the data acquisition box. They go into an encoder to generate the telemetry stream out. Typically, hypersonic missiles are military, so encryption is a requirement on those, and they go to a transmitter. There's also a flight termination receiver on board. That's always kept separate from the FTI system itself for safety of flight reasons. So sensors, typically temperature, strain, vibration. One you see more and more in hypersonic missile systems is a heat flux sensor. We don't normally see these in regular flight tests. These are small devices that measure the amount of heat traveling through the body of the device. Avionic buses, serial data, GPS, video, whatever other data, they all have to be captured. So the data acquisition and encoder, what this does is it gathers the sensors from the sensor, data from the sensors and the avionic buses, encodes it into PCM or Ethernet, and transmits it to the ground in real time. Right, so for captive carry, typically a lot of the data is recorded on board the aircraft that's carrying it. If the vehicle itself is recoverable, you might want to put onboard recording into your configuration. Encryption is something we're seeing more and more of, particularly in the military world. This data is always sensitive, depending on whether it's a commercial hypersonic airliner or a weapon system. Data privacy is necessary on hypersonic missile test programs. And they have to be able to decrypt the data on the ground in real time. So you have to have matching keys up and above. In the US, it's typically type 1 encryption. Outside the US, it's AES 256 generally used. The transmitters as well that are on board. These missiles fly very fast, very high, very long distances. So you're traveling over multiple areas. So you may have to change transmission band as you fly. Because you can use L band in one place, you can't use S band somewhere else, C band. So multi-band transmitters are necessary. Controllable power in the transmitters also saves on battery usage and thermal dissipation. The FTR, the flight safety, the flight termination receiver. This combines with tracking transponder, flight termination, and safe and arm functionality, and its status is reported through the telemetry. So it's monitoring the status of the system, and it's reporting its status back to the telemetry stream. It's always kept separate from FTI, what they call black and red separation. It monitors the system power, position, critical system parameters, and system safety status. And if something goes wrong, a kill command comes up from the ground. So you need a bidirectional link for that. There is talk of autonomous systems to replace the man-in-the-loop systems, where the flight termination receiver can decide itself something's gone wrong enough and it can terminate the flight itself. There's a debate going on about that. Again, for flight termination, you need bidirectional comms. You need to send a signal back up to the missile to tell it to disarm itself. So what I'm talking about here is combining all the requirements for an FTI system for a hypersonic missile into a very small package. So we're looking at TTC's MDW 2020 stack. This is miniature double-wide stack. It's 127 meters wide, 67 millimeters, 127 wide, 67 across, and the height depends on the configuration of the modules. Where we have a configured stack with all the elements you need for a hypersonic missile test system. It has an integrated transmitter with its own power supply. It has encryption built in. It has a PCM encoder interface, power amplifier built in, your data acquisition modules and your power supply for those as well, all built into a very, very compact stack. This is going to be demonstrated live at the ITC show this year in Vegas. If any of you are going. So this is what the miniature double-wide stack. So it's taking the miniature stacks from TTC, putting them side by side with instead of a long, tall stack, it divides it in two, puts it side by side with a custom-built power supply. There's over 200 data acquisition modules available. There's 50 watt and 200 PSU options, 200 watt power supply options integrated into the base plate. There are standard and rugged mount options, and there are master remote configurations to support multi-stage vehicles. So this type of configuration, when you add in the encryption and you add in the built-in transmitter and add in the PCM encoder, we feel is ideal for hypersonic missile test. Thank you. Any questions?
How do you keep the red? Does that unit sort out the red and black power for the encrypted?
It does, yeah, it does. There's a separate power supplies for each of them. They're not running off the same power supply. So if you go back to the presentation for a sec.
Can we go?
If you go back to here, there is a separate power supply for the transmitter for the transmitter and a separate one for the data acquisition unit. So the red and black separation is maintained.
Talk about telemetry and sort of hypersonic. What sort of speed? What's the speed you get to the Doppler effect? What is the problem with this actually?
I wouldn't be able to answer that. Don't know that actual number myself. I'd like to know the answer to that. If anyone else can answer that. We have an answer over here.
No, I was going to say I can't answer that. So thank you very much for the presentation. I just think looking at you see the market for this type of instrumentation, the digital Hypersonic, is that very much market that you expect that in both from the US military? You see that being more widely used in Hypersonics globally, and actually is there a civil aerospace spin-off for the miniaturization that you're?
Oh, there is. I mean, that's not. It's just a configuration that we feel fits into this market very well, right? And we can. There's no, because it's AES 256 encryption. It's not just for U.S. military. It can be sold outside there. It's not ITAR or anything like that. You know, I wouldn't be allowed to talk about it up here if it was. You know. So, you know, so obviously, yes, this double-wide stack is a huge range of modules in the miniature form factor from TTC. You can put any of them together in that stack. This is just a nice combination of everything you need in one package. You know? Okay, thank you very much, everyone.